Pre-flight 101. The course that will keep you wings. 5. Aircraft systems and structures. 5.6. Fire protection and miscellaneous systems. Hello again. Until now, you've learned a lot about the most important systems in your aircraft: the engines, electrical components, the oil system, the fuel system, etc. In this last lesson, we are going to be learning about some of these systems we left unspoken in the previous ones, as they are important as well. Again, if you want to know more or review any of the systems shown, go to your POH and look for the Systems section. In this chapter, we'll be taking a look at fire protection, fuel shutter valve, master switches, firewall, and fire extinguisher. Also, the vacuum system needed to energize some of the most important systems on board, such as instruments. Then we'll talk about the ventilation system, that is the one in charge for the air quality inside of the cabin. CO detectors, what are them and how do they work? Holds, a brief description of the holds and baggage area of this aircraft. And the pitot-static system, the stall warning and the temperature gauges. For fire to happen, three things are necessary: heat, fuel, and oxygen. If we can get rid of at least one of them, we'll be able to contain the fire. As you know, the main producers of heat in a small airplane are usually the engine and the electrical system, which malfunctions could create sparks or flames, creating a risk of fire. In order to minimize the risk of fire related to an electrical system, for example, we have the breakers, as we've seen before. In case of a fire, it might be necessary to use the master switches, alternator, battery, or avionic switches, or manually isolate some of the systems via the breakers. To protect ourselves and the occupants of the aircraft from fire, flames, or heat coming from the engine, the Cessna 172 features a firewall. We can see it now pointed out with an arrow on the screen. The firewall is also the junction point of the engine with the fuselage. Do you remember how many junction points were connecting the fuselage and the engine in the Cessna 172? Exactly, 4. Yes, you remember. That's good. As we've studied before, the fuel system also features some valves. Anyway, this is our way to protect ourselves from heat. Alright? We have the master switches, we have the breakers, we have the fuel fire, the firewall, okay, between us and the engine. And we also have these kind of gauges or protections, breakers, and more controls in order to get rid of that heat that could be caused by a fire. Now we have studied before the fuel system. This fuel system features always a fuel shutter valve, or in the case of the Cessna 172 November, it features a position of the selector valve that closes all supply of fuel in case of a fire. We can see right there that that is the valve that cuts all the supply of fuel. As I said before, if you can cut one of the points of the triangle, if you cut heat, or you cut fuel, or you cut oxygen, you'll get rid of the fire. In order to control the flow of oxygen entering the cabin, we can also regulate the vents and open and close the windows and doors as required, as you can see right there. We're going to be seeing this system just in a bit in detail, but that is basically it. We also have a fire extinguisher. It is mandatory in most of the states to carry a fire extinguisher on board. It's usually located between both seats and it's accessible. There's just one little thing that I want to tell you here, how to check a fire extinguisher. Usually fire extinguisher, when you have to check them, you have to check for two things. The first thing is that green line that you can see right there where my pointer is. That green line is going to allow us to check the pressure of the gas or liquid that is inside of the fire extinguisher. If the needle is in the green, that means everything's okay. If the needle is not in the green, that fire extinguisher becomes unserviceable. Okay, we have to check the fire extinguisher every time we fly an aircraft. Also, we have to check for the validity or expiry date. We need to check this kind of sticker that is around it. It's sometimes drawn or painted or written by hand. Sometimes it's written with a sticker or something, but you have to look for a date. That date is usually the date of expiry of this fire extinguisher. So if the fire extinguisher is expired, you cannot depart. You need to find a good one. Okay, so that's pretty much it. That's how you check a fire extinguisher. Now, we've talked about the instruments that an airplane features. Some of these systems, such as the horizontal situation indicator, need a gyro. Remember what a gyro is? Yeah, it's a metallic device turning at high speeds at all times. There are two ways to do this. There are two ways to keep a gyro moving all the time. One of them is by using electricity. Some of the big airplanes carry these big instruments, these expensive instruments that are connected to this electrical source that is going to allow us to have better precision and basically a system that is more reliable. However, in this small aircraft, we prefer to move these gyros via vacuum, because if we lose the engine, we don't want to lose all the instruments. So most of the instruments requiring this rotation created by the vacuum moving these gyros, such as the directional indicator right here and the attitude indicator right there, the artificial horizon also called, we connect them to the engine. All right, so this is the second way to do it, is by using a continuous vacuum created by the engine. So we're going to talk now about this vacuum system of the Cessna 172. The first thing is the inlet, right? We have a filter. The air is coming in through the engine. It might be dirty, it might be full of particles, full of dust, so we want to clean it out. As you can see, after that, most of the air coming from this engine, most of this suction, right, is going to go straight into the instruments, right? It's going to be going to the attitude indicator, to the vacuum gauge, in order for you to get that reading on the vacuum that these systems are getting, and also to the directional indicator. Those are the two systems that you have in your aircraft that are going to need this suction. After that, as you can see here, the rest of the air is going to continue moving and move through a vacuum relief valve. This valve is in order to prevent overpressure in the system. Okay, imagine at high RPMs or at certain conditions with low temperatures, high densities, the pressure inside the system or the pressure moving through the instruments might be too high. Okay, the systems are really complicated, really sophisticated pieces of equipment. So we don't want too big of a pressure running through the instrument. So that's why we have that vacuum relief valve also fitted. This air is going to continue looking for the outside of the plane, and it's going to go out through the overboard bent lines, right? The air is going to go out of the airplane again after having moved these gyros required for working with these instruments. Now, in order to ventilate the cockpit, the Cessna 172 counts on three subsystems, to say it somehow. We have the ventilation plumbing, the heater, and the air conditioning. These two last ones are also optional and may not be fitted in your aircraft. Yeah, some hot places need a an air conditioning system fitted to the aircraft. Some others need a heater fitted to the aircraft. And in some other places, they just don't fit anything. That's just a personal choice. In this case, maybe it's a choice of your school. It's not your choice. But anyway, the only one that is always going to be there is the ventilation one, is the ram air coming from the outside straight to the inside. That is going to allow us to ventilate that cabin and that cockpit and basically keep us alive, right? So first things coming in right here, we're gonna take a look at the diagram. These are the inlets for ram air. Okay, so we have the highest ram air right there in red. That ram air is gonna go through a different mixer, so that air is gonna be hot. Okay, that air is gonna mix with the exhaust muffler shroud, right? With this. You might remember from previous lessons we talked about the exhaust air being used to heat the carburetor heat and also heat the air that was warming the cabin. Well, this is where it is. Okay, that's that box right there. This box right here is basically where that heat exchange happens, right? If we go down here to the code, we can see that the ram air is coming in cold, it's ventilating air, and then it becomes hot, right? It becomes bold black. Also, we have these three ram air that are painted now in blue. This is fresh air coming into the cabin. This first one right here is going to be mixing with the hot air coming from the heat exchanger. This is just probably logic for you, but I'm just gonna call it out for once. If you mix it, you're gonna get that temperature control. The more hot air coming in, the hotter the air in the cabin is going to be. The more cool air, the cooler the air is gonna be. Okay, and you do that with this. That control right here is a push-pull control that you have in order to control the temperature of the flow that is coming inside of the cabin, right? We have this mixing unit right here, mixing hot air with cold air, depending on the inputs given to the valves, right? And this is gonna tell what the temperature of this outlet air is going to be. Okay, good. So that's for us, that's for the pilots. Now, what do we have for the people that are sitting on the back? We have these two lower ram air inlets that are fitted on the wings. If you look at the wings, at the leading edge of the wings, just next to your cockpit windows, you're gonna see these two ram air inlets. This is not heated, this is not cooled, this is just air coming from the outside, filtered and into the inside. Okay, so for the people sitting at the rear cabin, we do not have heater. Okay, they are just getting ram air. Now, as I told you before, we have these controllers, then we have the mixing unit. All right, that is going to bring us air. That is going to be temperature control in the front, but not temperature control in the back. And that's basically this ventilation system. If you have an air conditioning fitted, the air conditioning is also going to be connected to this venting plumbing. Okay. Now, this little thing we see now on our screen is a CO detector. You might be thinking, well, what is this? Is this kind of, I don't know, a chemical thing? Is this to detect something on the fuel? I don't know, it doesn't, what is this? Anyway, CO, or carbon monoxide, is a gas that might form inside of the cockpit due to leaks in the engine. Okay, a carburetor engine or an injection engine might form some gases that are gonna be coming inside of the engine. Okay, this is not happening every day, but if it happens, these gases are usually highly toxic, and this is a threatening situation for us as we are mid-flight and we don't want to get intoxicated, right? We don't want to get sick. Now, this gas is highly toxic, and the bad thing about it is that we cannot see it or smell it. All right. So if you don't see it and you don't smell a gas, you cannot really detect it by yourself, right? I mean, the gas is gonna make you dizzy, it's gonna make you kind of, um, you know, slow when reacting. It's gonna make you happy. Actually, this gas has been proven to make people too happy. You know, happy in a bad way, like I'm dying happy, that kind of happy. Well, you get the idea. This gas is not good. I wouldn't be breathing this if I could choose. Anyway, so we need something to detect it. In this case, there are two kinds of detectors. The one we can see in the screen, basically, and an electronic unit able to detect a CO leak and relay the information to the Garmin 1000. So, it says here, really easy to read, dark spot indicates danger. So, this is a chemical thing that is going to turn blue or black when in contact with carbon monoxide. Okay, so if you ever turn your head towards this and it looks black or dark, it means that you have a carbon monoxide leak and you should act appropriately. Well, it's act appropriately against carbon monoxide. Opening windows, opening vents, see if something's wrong with the engine and trying to land as soon as possible. All right. Anyway, the other one, as I said, is an electronic system. It basically works in the same way as this one. It has a way to detect this CO and it's going to relay this information to the Garmin 1000. So you get this information as a big red advisor in your screen. Hey, you have CO detection, something's going on, something is not right. Okay, so that's basically how this system works. Now, the hulls of the Cessna 172 are basically an empty compartment behind the rear seats made for carrying baggage safely. So yeah, basically we have the baggage area 1, baggage area 2. This diagram has been taken from the weight and balance section from your POH. There is something you need to know. You might remember it from the limitations section, but I want to actually get onto this again. Is the weight limitations for the baggage area. So the baggage area 1 holds 120 pounds of load. Okay, so that's the maximum load for the baggage area 1. The baggage area 2 is a smaller area that was created, I think it was in the Cessna 172 mic, to increase this loading capacity. But we have to be careful with this. It increases loading volume, but it doesn't increase load. Okay. You might be thinking, I really don't understand what you're talking about, man. I'm gonna explain it to you. The maximum weight of the baggage area 1 was 120 pounds. The maximum weight of baggage area 2 is 50 pounds. But both of them combined are 120 pounds. Which means if this area is fully loaded, 120 pounds, how much weight can you put in by this area? Exactly, nothing. Okay? The limit for this one is 120. The limit for this one is 50. However, combined, they shouldn't be carrying more than 120 pounds. Okay? So, the maximum total hold capacity of the Cessna 172 is not 170, is 120 pounds. That's a typical exam question. It can get you confused. So yeah, basically you need to know this to fly safely. So the last system we're going to be reviewing in this is the air data system. This system we're going to include the stall warning system, we're gonna talk about it. However, I will tell you more about the stall horn in the procedure section. Also, we'll be talking about the pedostatic system and the air temperature measurement, and we're going to be reviewing how they integrate into the Garmin 1000 avionics. So let's get started. As you know, and we have seen in previous section, some instruments are related to air data. This means that they require certain reading on the air parameters to be able to display this information. The left wing has a pitot tube attached to it. This tube measures the total air pressure from the air, right? The air is coming in, so it's measuring the total pressure. Then to the side of the aircraft, we have the static port. Okay, the static port is basically a hole that is made on the fuselage that is going to measure only the static pressure. Okay, then we have this temperature reading meter or temperature probe, right? That is usually located on the top of the aircraft. Sometimes it's to the side, depends on the model, but basically this is how it looks. Okay. Now, what do each of these systems give us, right? If we relay the pressure, the total pressure, and the static pressure, we're gonna get air data. As you might remember from your ground school, if we want to get the dynamic pressure, therefore the speed, we need to subtract the static pressure from the total pressure. So total pressure coming from the pitot tube minus static pressure coming from the static port, it's going to give us the dynamic pressure. The dynamic pressure is going to give us the speed. Okay, in the aerodynamics section I will give you the formula for speed, for lift, for the stall. So you see all these formulas. I'm pretty sure you already know, but we're just going to be talking a little bit about them. So the pitot tube we talked about, the static port, and the outside air temperature gauge or temperature probe, or however you want to call it. Okay. Then, so what happens if we mix the pitot tube with the static port signals? We're gonna get the airspeed indicator. Okay, the airspeed indicator is gonna be drawing the pressure from the pitot tube and from the static port. Okay. Then from the static port, it also gives us the altitude. How? As you might remember from your ground school again, from previous lessons, wherever, with increasing altitude, it comes decreasing pressure. So if we make this system be able to sense the decrease in pressure, we can get this increase in altitude. Okay, that's how the system works. And we also get the vertical speed, as we talked about in the instrumentation section. You can now go again and take a look and maybe review some topics from this from that section. The vertical speed indicator is basically two anaeroid capsules combined, two altimeters combined, which means that they are going to be comparing each other all the time to give you a reading, whether if you are climbing or descending, and they're going to give you in feet per minute the vertical speed that you are achieving. Okay, and that's done only with static pressure. Good. Now the OAT gauge. The OAT gauge is going to give us this reading on the screen in the Garmin 1000. We use the temperature for planning purposes, for performance purposes, but the Garmin 1000 actually uses the temperature for giving us a more precise speed. Okay, so the computer can do many calculations we cannot do while we fly, and that's something we will be talking about and discussing a lot on the Garmin 1000 course. If you have that course, take a look at it and you're gonna see how the temperature actually gets combined with all the data, and instead of having to be looking everywhere, you get all the information just in one screen. Anyway, after this, you have actually finished this section. So you finished this section, as I was saying before, for the Cessna 172. You finished the system overview. We talked about electrics, fuel pumps. We talked about everything. I really recommend you to review the systems in the POH for two reasons. The more you review them, the better you will learn them, and the most time they will stay in your head. The second reason is that, as I told you probably 1,000 times already, you might be flying an aircraft that differs a little bit from mine. You might be flying in a country that differs from the laws that are in my country, or at least the laws that are investigated for this project. So take a look at your POH, take a look at your documentation, and try to find these systems. Try to inform yourself of the little changes, those little things that might not be the same. And hey, who knows? You might find you have air conditioning. If you have air conditioning, yeah, I really would like to be you. I don't have air conditioning in my airplane, and that is bad. Anyway, yeah, I just want to see you keep learning. Um, this lesson's finished. You can take the test now. I will see you on the next section. Cheers, guys.